Welcome back to CS111. In this lecture, we're going to be looking at another common type of data structure, the queue. We'll talk a little bit about queues in general. We'll see how we can do a linked implementation, and then we'll do a demonstration of using that. And then we're also going to do an array-based implementation. When we were working with stacks, we saw that they were a last in, first out type of data structure. The item that we added most recently to a stack is going to be the one that will first be removed. Queues are sort of the opposite of that. They're first in, first out. So the thing that we added to the queue first is going to be the thing that we remove from the queue first. In the real world, you're undoubtedly familiar with queues from when you go to check out at a store. The checkout line is an example of a queue. The first person who gets in the line is going to be the first person who goes and gets up to the cashier and is able to go and complete their purchase. Queues have a number of uses in computing as well. Just like we can only have one person checking out at a given checkout line at a time, there are a number of resources like printers where we might have multiple programs wanting to use that resource, but only one of them can actively use it at a given point in time. I can only go and print one document at a given point in time. I have to complete printing that document before I can go and start doing another one. Queues allow me to go and share in a fair manner access to those resources. Whichever programs want to go through and use that resource, if they're not able to use it right at that moment because it's busy, they go and line up in order based on when they requested access to that resource. So if I'm trying to print when I submitted a print job, and whichever one got there first to go and request access, that's going to be the one that's going to get access the next. You'll also see queues used a lot if we're working with network communications, so things like sockets and pipes. Depending on the protocols and how we go and use things, a lot of times when we're going and receiving data over network connections, the data is going to effectively come to us in a queue where it'll line up based on the order that it was sent in, if we're going through using something like TCP. Queues are also used for when we go and type in things on the keyboard. Our computer has an input buffer to go through and keep track of the keys that we go and press on the keyboard. And kind of by necessity, those are also a queue, because I want to make sure that when I go and type in something, that the computer goes and processes it in the same order as I actually typed it in. The queue goes and enforces that. When we're working with queues, they're known to have a front end and a rear end, sometimes also called head and tail respectively. When we go and add things to the queue, that process is called enqueuing, and that happens at the rear of the queue, so the back of the line. When we go and remove things from the queue or dequeue them, that happens at the front of our queue. As we go and dequeue things, items that are at the rear slowly work their way up towards the front every time another thing gets dequeued. This is a little bit different than like with a stack, where all the operations are done at the top of the stack. Let's think about what sort of operations we're going to want to support with a queue. We're going to have to go and code up an interface here so that we can go and have different concrete implementations that'll all be coded against that interface. And we're going to go and design our interface so that it'll have a generic type parameter so that we can control a specific type of data that we want to allow to be stored in our queue. Let's go ahead and figure out the methods that we need to have to support our queue. Obviously, we're going to have a way to create a new queue. The constructor in our eventual concrete implementation class will take care of this for us. And since constructors don't go inside of interfaces, we're not actually going to code this up right now. We do need to go and have a method for being able to add items to the queue. This is called enqueuing the item. We're going to name our method enqueue, and it'll take the item of type T that we're trying to go and add. For the queue, I'm envisioning that my implementations are not going to have any size limits, either because I'm going to go and use a resizable array, where I'm actually going and changing the size myself, or because I'm using a linked implementation. So I'm going to have my enqueue method go and return a void value, and I'm not expecting that it should normally go and throw any exceptions. I'm actually going to allow it to store null values. I need to have a method to be able to go and dequeue things, remove them from the queue, and I'm going to call this dequeue. This method is not going to take any parameters. With queues, the operations to go and remove things happen at the front of the queue. I don't have a need for a method to specify the thing that I want to get rid of, because I'm just taking whatever's at the front of the queue, and that's going to be my T return type because I'm storing T values. In this implementation, I'm going to throw a no such element exception if the queue is empty. This exception type is used by Java's built-in implementations of a queue when there's nothing to dequeue, and I'm just choosing to match it instead of using illegal state exception, which would also be an appropriate type of exception here. I'm also going to include a peek method that'll allow us to see what's at the front of the queue without actually removing it. This method is also going to throw no such element exception if there is nothing in the queue. I'm going to have an isEmpty method that'll allow me to see if there's anything in the queue. So return a Boolean value. I'll also have a size method that's going to return an int telling me specifically how many things are in the queue. The last method that I'm going to provide is toArray, which will return an object array. In this implementation here, I'm choosing to omit a clear method, which would get rid of everything that's in the queue, because we can go and do that on our own pretty easily using a loop if we actually needed to go and clear out the queue. So just in the sake of brevity here, I'm going and omitting that method. Let's head into Eclipse and we'll see how we can code this up. Here in Eclipse, I have a new project for us as we work with the queue interface. Let's go ahead and create a package for our interface, and I'm going to right click on the source folder. I'll go to new package, and I'm going to follow the same naming convention we've been using. This is going to be edu.wvu.cs111.q8et. I'll click finish. Inside of this package, I'll go ahead and make a new interface. So I'm going to right click on the package, go to new interface, and I want to call this queue interface, and I'll click finish here. For this interface, I want to make sure that I go and add a generic parameter, and I'm just going to call this T, since that's the most commonly used variable for generic type parameters, for the first one at least, so that we have a way to go and specify what type of data we're going to store in the queue. And then I'll provide some JavaDoc for my interface here. So this is an interface for representing queues. Go ahead and list my author name, and then for that param T, that is the type of data to store. Inside the curly brackets, let's go ahead and list the methods that we identified. I'm going to do these in alphabetical order. We'll start off with a dequeue method that's going to return a value of type T, and this does not take any parameters. It's just going to remove and return whatever is on the front of our queue. I'll have a void method called enqueue that will go and take an item of type T to be added to the queue. I'll have a Boolean method called isEmpty so that I can find out if there's anything in my queue. I'm going to have a variant of the dequeue. This one's going to be called peek. That'll return the item that's at the front of my queue without actually removing it. So since my queue is storing t-type items, this is going to return t here. I'll have an int method that'll tell me the size of how many items I have in the queue. And then I'm going to have my toArray method that'll return an array of objects. And then I'll go and provide some JavaDoc for each of these methods. In my JavaDoc, I went ahead and noted the two methods that are potentially going to throw exceptions. Since these are unchecked exceptions, I normally would not use the throws keyword. Down here in the documentation for my toArray method, I added a little bit of detail to the description here, and then I can actually even add more to the return statement here to go and explain that index 0 is the front of queue, so that I know when I go and call this method how things are laid out. In my JavaDoc, I went ahead and noted that the peek and dequeue methods throw that no such element exception. Since these are unchecked exceptions, I normally just put them in the JavaDoc as opposed to listing them with the throws keyword. Down here in the toArray methods documentation, I went and explained how the array is laid out. So I'm saying that element 0 is the front of the queue. This is important for somebody using this method because there is a definite front and rear of a queue, and we want to make sure that we know what end we're dealing with when we go and get the data from it here. I have to be careful when I go and write my method that I actually code it so it matches what this JavaDoc says. So when I go and implement the toArray method, I need to make sure that I end up with an array where element 0 is the front of the queue, and then, sort of implied by that, the highest numbered element is going to be the rear of the queue, or the most recently added thing. One approach for implementing our queue is going to be with linked nodes. And for this, we can use the singly linked node class that's part of the provided starter code and that we created earlier in the semester. This approach is going to give us a queue that is capable of storing any number of items. Here in Eclipse, I've imported the starter code for this lecture, which includes this nodes project here. I also went ahead and made a new project called linked queue. Before we go any further, we're going to need to adjust the Java build path for this linked queue project so that we can use the code that's in the other two projects. I'm going to right click on the linked queue project here and go to Properties. I'll go to Java build path. I want to head to the Projects tab. Here, I'm going to click on Class Path and then choose Add. And I'm going to tick the box for both the Nodes project and my Queue Interface project. I'll tell it OK, and then I'm going to apply and close. And that'll allow Java to find the code from those other projects when I'm going and working on things here in linked queue. Let's go ahead and add our package. So when I right click on the source folder, I'll go to New Package. It's going to be edu.wvu.cs111.linkedQueue, and then I'm going to add a linked queue class. So I'll right click on the package, go to a new class. I'm going to call this linked queue, and down here for the interfaces, I'll click Add, and I'm going to go ahead and start searching for queue, and then I'll select Queue Interface. And I'm going to click Finish. You can see here I have this new class created. I'm going to add the tgeneric for it, and I'll provide some JavaDoc. So this is a linked implementation of a queue. I'll list my author name and a description for the generic parameter t as the type of data to store. And I'm going to go ahead and have Eclipse create stubs for the different methods that are defined in the interface. So where we have the red squiggly lines here under linked queue, I'll go to the quick fix and say to add unimplemented methods. We're going to need to create 3 fields inside of our linked queue class. We'll have variables that'll keep us connected to the front and rear of our queue, and then also a field to keep track of the size of our queue. So for our front node here, we're going to create a protected field, and it's going to be of type singly linked node with the T generic, and I'm going to call it front node. I'll make another protected field of type singly linked node with the T generic called rear node. So this will allow me to get to the front and rear of my queue. And then I'm going to create a protected int called size. I'm going to hover over the red squiggly lines here for singly linked node, and I'll fix the problem that Eclipse is marking by importing our class. And then I'll go ahead and create some Javadoc. When we go to create a new linked queue, there's two major things that we're going to have to do. The first is we're going to have to set our fields that point to the front and rear nodes to null. Both of them are going to need to be null. And that's basically because we don't have anything in the queue right now, so we don't have any nodes that we need to be pointing at. We also want to make sure that our size field is set to 0 since we don't have anything in the queue either. Technically speaking, we could go and omit this constructor because we're just setting the values to their defaults that they would be anyhow, but I do like to go and create constructors, especially with more complicated classes. So let's go ahead and make one. It's going to have a public access modifier, and we'll call it linked queue. We'll go ahead and set our front node and rear node to null to reflect an empty queue. So we're going to say this dot front node is equal to null, and this dot rear node is equal to null. And then I'm going to go ahead and set the size to 0. So I'll do this dot size equals 0, and we'll give it a little bit of Javadoc here. So this is a constructor for a new queue of linked nodes. The process for enqueuing new items in our queue is going to vary depending on whether or not there already is stuff in the queue. Let's start off by looking at the situation where we have an empty queue. This is the simplest implementation here. With this version, we're going to create a new node to go ahead and store our value. So you can see this new node here is storing the value A. Once we have that node made, we need to go and set both the front node and rear node fields so that they go and point at that new node. And then we'll go ahead and increment size to reflect that we have a new item in our queue. Things are a little bit more complicated when the existing queue has things in it. So in this example, we have 3 nodes, A, B, and C, that contain items that are stored in our queue. I'm going to go ahead and add another node to store a new value. So let's see how this works. We'll go ahead and create our new node. That's going to be D here. We're going to go and take our existing rear node, so that's C, and initially its next node field is going to be null because there was nothing else after it in the chain. We're going to update that so it goes and points at that new node we just made. Once we've done that, we're going to go ahead and update the rear node field for our queue to go and point at the new node as well, reflecting that it's now the rear of our queue. And then we can go ahead and increment our size field so that we have a updated count of how many items there are. In my enqueue method, I'm going to go and actually check to see if there's anything in my queue so that I can follow whichever of those two processes is appropriate. So let's go ahead and create our actual body for isEmpty to go ahead and make that check. Here, what I'm going to do is just return if the size is 0. So I'm just going to return the result from going and evaluating the expression, this dot size equal to 0. Assuming that I've coded everything correctly, size should be 0 at the same time that front node and rear node are null. Java's built-in implementation of a queue actually goes and uses this check here to see if the size is 0. It does not look for null with front node or rear node. Now let's go back and tackle the enqueue method here. So the first thing that I'm going to do is I'm going to go ahead and create that new node because that step is going to apply whether or not there are things already in the queue. So I'm going to say var new node equals a new singly linked node with that T generic, and I'm going to call the version of the constructor for singly linked node that just takes one parameter, the item that I'm trying to go and store. That will go and set the next node field for that node to be null. Once I've got my node made, I'm going to go and check to see if the queue is empty. I'm going to do that by using an if statement here to see if this dot is empty. If it is empty, this is going to be the first thing in the queue. So I'm going to say this dot front node is equal to my new node. I'll have an else clause to handle where there are already things in queue. And for this one here, I need to go and update the existing rear node's next node to point at my new node. So I'm going to do this dot rear node, and since I configured my singly linked node class to use getters and setters, I'm going to use the set next node method here. And I need to pass it an argument with the node that I want it to be pointing at. So that's going to be new node. So this is going to get from the front end either directly to our new node or through the chain to the new node, but I still need to go and update the rear node field. So we'll do that here. So I'm going to say this dot rear node equals new node. And then I want to go ahead and update my size by incrementing it. So I'll do this dot size plus plus. And this will go ahead and add my new item into the queue. In addition to a method for going and removing and returning the front item in our queue, we're going to have a way to be able to peek at it to see what's there without actually removing it from the queue. So in this case here, our front item is A. The way this method that we're going to be implementing here, our peek method, is going to work is we're going to start off by checking to see if the queue is empty. If it is, we're going to throw no such element exception. Assuming that it's not empty, we're just going to go and return the value that's stored in that front node. Here in peek, I'm going to start off with that check to see if our queue is empty. So I'm going to do if this dot is empty, then I need to throw that exception. So I'm going to say throw new no such element exception, and I'm going to go ahead and pass the message along with it that the queue is empty. I've got some red squiggly lines beneath the no such element exception class because I'm going to have to import it into my code, and it's coming from java.util, so I'll use the quick fix to handle that. Once we've made sure that we actually have something in our queue that we can go and return, we're going to do that. So we're going to return the data from the front node. So for this, I'm just going to do this all in one line here. Return this dot front node. I'm going to go ahead and get the data from that. And then I'll go and return our value from the very front of our queue. Just as the process for going and adding things to the queue varied depending on how much was in the queue already, removing from the queue is also going to vary depending on how many items are stored. First of all, let's take a look at the case where there are more than one item in our queue. So even when we're done here, there's still going to be something in the queue basically. So I've got 4 values that are enqueued right now. We're going to start off by going and creating a variable to keep track of the value from the front node that we're going to be removing. And we can actually use peek as part of this process here. So I've got this variable that's going to store A in it. Once I've done that, I'm going to go and basically bypass that front node in the chain. I'm going to update the front node field to go and point at the next node that came after the existing front node. So now B is going to actually be our front node here going forward. Once I've done that, I can go and decrement the size field. So now we're down to 3. And then I can return the value from the node that we removed. So I'm going to return that A. The process for removing when I only have one thing in the queue to begin with is a little bit different. here we're going to end up with an empty queue once we've completed this operation. Things are going to start off the same as with the other version of dequeuing. We're going to go ahead and store the value that will be removed inside of a variable so we can keep track of it. But once we do that, things are going to shift. Here, we're next going to go through and take our front node and rear node fields, and we're going to set them both to null, which means that we have an empty queue. We'll then go ahead and decrement the size field, which will end up setting it to 0. Once we've done that, we can go ahead and return the value from our removed node. And once we go ahead and return, what's actually going to happen is Java will see that there was nothing else left pointing at the node that we created. So it's going to do something called garbage collection to go ahead and free up its memory for reuse by something else in our program. For our dequeue method, we're going to start off by going and calling peek. And this will do two things for us. The first thing is that it's going to go ahead and get us the data that's in that front node. But it's also going to take care of handling the case where we have an empty queue and need to throw the no such element exception. Since peek goes and checks for that condition, we don't have to do that here in the dequeue method, so it saves us a little bit of extra code. Once I have the data that was in our front node stored, I can go ahead and update the front node field so it goes and points at the node that came after the front. Now in this case here, whether or not there's a node after the existing front one, I don't need to differentiate. One line of code is going to work. And that line of code here is going to be for the front node going and getting the next node. If there's another node after it, that's going to become the new front. If there was only one node to begin with, front node is just going to end up being set to null. The case where things differ in terms of how we need to go and treat the case is with the rear node. And what's going to happen here is we're going to go through and take a look at front node after we've gone and updated it. So we're going to see if the updated version of front node is null. And if so, then that means that we now have an empty queue. So we'll go ahead and set rear node to null as well. Once we've gone ahead and updated our fields for what they're pointing at, we can go and decrement the size. So I'll do this.size minus minus, and then we can go ahead and return the data that we got out of the front node. Our size method is going to be really straightforward. This one is essentially just a getter. We're going to return this.size. Our last method is going to be to export the contents of the linked queue to an array. And for this, we just need to go and iterate over all of the nodes that we have. Even though we have both a front node and a rear node, this process for the queue is going to work the same as essentially what we've done with our other linked implementations. We'll create a current node variable that's going to point at the front node, and then we're just going to go through and keep on iterating until current node becomes null, and at that point we'll stop looping, and then we can go ahead and wrap things up, which in the case of our toArray method is going to be actually returning the array. So let's go and see how we'll code things up here. In our toArray method, we're going to go ahead and populate the contents of a new array as we iterate over our linked chain of nodes. Let's start off by going ahead and creating our new array. I'm going to call this destination array, and it's going to be an array of the object type. Because of how generics work with Java and the fact that I don't have any parameters on this method, I can't go and make it of the same type as what I'm storing in my queue. Object is the closest that I can go ahead and get. Once I have the array created, I'm going to go ahead and start to iterate over my chain of nodes. For this to work here and be able to populate things as we go, I'm going to create this int called IDX, and I'm going to set it to 0. I'm going to make my current node variable, and we'll set it to the front node. And then we'll go ahead and loop while the current node is not null. And assuming everything is working correctly here, with our size field, we shouldn't have any issues of overrunning the end of our array. We could actually add a separate check for that, but I'm going to assume that I've coded everything correctly and that that check would be redundant, so we're just not going to do it. Inside the loop here, we're going to go and store the value of the current node in our destination array. So I'll say destination array sub idx is equal to current node dot get data. So I'm going to get the data value that's stored in the node that we're looking at right now. Once I have done that, I'm going to go and increment the counter so that next time through we're looking at the next element to go and store our data. And then we'll go ahead and move on to our next node. So I'm going to say current node equals current node dot get next node. And this is going to eventually lead us to the point where current node is null once we've run out of nodes to check, and then we'll go and fall out of that while loop. When that happens, we can go and return destination array. Now that we've finished coding up our linked version of a queue, let's go into Eclipse and create some code to demonstrate its use. Here in Eclipse, I'm going to make a new project. So I'll right click in Package Explorer, go to New, and I'm going to choose the Java project option. I'm going to call this project QDemo, and I want to make sure that the create module-info box is not checked, and then I'll click Finish. I'm going to have to create a class here, but before I do that, I want to make sure that the Java build path is good for this project. That way we're able to go and reference the code that we're using from the other projects in this project. So I'm going to right click on the QDemo project and go to Properties. Under Java Build Path, I'll go to the Projects tab and click on Class Path. And here, since we need linked queue and queue interface because they're going to be directly referenced in our code, and I know that linked queue also goes and uses nodes, I'm going to go and check that box as well. I'm going to tell it OK. You can see that these three projects are listed here under Class Path, and I'll click Apply and Close. I'm going to make a new QDemo class here in the source folder, and I'm not going to bother about any package for this. This is really just intended for use inside of this project, so package I don't actually need here. I'm going to right click on the source folder, we'll go to New Class, and I'm going to call this QDemo, and I'm going to check the box to create a stub for a main method. Go ahead and have Eclipse handle that versus me having to do it myself. And I'm just going to quickly drop in some Javadoc here for sake of completeness. Inside my main method, I'm going to start off by going and creating a new queue. And I'm going to go and call this queue, just be descriptive that way there. And I'm going to have it be of type queue interface. That way, if we want to go and swap out the concrete class that implements queue interface, it's going to be easy to do. And for right now, I'm going to store strings. So I'm going to call this queue, and then I'm going to set it equal to the class instance that I get back when I call the linked queue constructor. So I'm going to say this is equal to a new linked queue to store strings, and the constructor does not take any parameters. I'll go ahead and use the quick fixes here in Eclipse to go and import queue interface and linked queue. And now that I have a queue instance, I'm going to go ahead and enqueue some things. So let's go ahead and do some cities along I-79, for example. So I'm going to say queue.enqueue, and we'll do Charleston. Let's go ahead and do Clarksburg, Fairmont, and we'll finish up with Morgantown. So we've got 4 things in our queue, and then we can go ahead and print them out and dequeue them one at a time as we do that. So let's go ahead and dequeue and print our values. So I'm going to do a while loop for this, and I'm going to say while my queue is not empty, then I'm going to go and dequeue, and I'm just going to feed the value that I'm dequeuing, its return value, directly into system.out.println. So I'm going to give that the value from queue.dequeue to go ahead and print. And when I go ahead and run this code, I should see my 4 cities in the same order that I added them to the queue, and in fact they are. So this is a quick and dirty little implementation here of how we can actually work with a queue. The other approach to implementing a queue is by using an array. And for our design here, we're going to set it up so that we will automatically replace the array, which has a fixed size, with larger or smaller versions of the array as needed. That way we eliminate any of the capacity limits that might otherwise restrict how much we're able to store. Let's go into Eclipse and see how we can code this approach up. I've created a new project called ArrayQ here in Eclipse, and I'm going to adjust the project properties to go and add our interface to the build path. So here on Java build path, I'm going to click class path and add, and I'm going to check the box for the queue interface project. I don't need to pull in any of the other projects because we're not going to be using their code, so I'll just leave those unchecked. I'm going to go ahead and click OK, and then I'll do apply and close. For this project, I'm going to add a new package to contain my ArrayQ class. I'm going to right click on the source folder and we'll go to new package, and I'm going to follow our standard naming convention, edu.wvu.cs111.arrayQ, and I'll click finish. I'll go and make my new ArrayQ class inside of this package. I'll right click on the package, go to new class, and I'm going to call this ArrayQ, and I'm going to say that it implements the queue interface. So I'll click on add here, and it's already got queue interface listed because I was working with it, but if not, you can always go and search for it. I'll go ahead and tell it OK. You can see it's listed down here under the interfaces, and then I'll click finish. Before I do anything further, inside the new ArrayQ class, I want to go and add the tgeneric so that we can specify what type we're going to be storing inside of our queue. And I'm going to hover over ArrayQ and have the quick fix for Eclipse to add the unimplemented methods. I'll also provide some JavaDoc for this class. So this is an array-based implementation of a queue. And then I'll finish out here with my author name and my generic parameter t as the type of data to store. Let's go ahead and create the fields that we need for our class. The first one's actually going to be essentially a constant. It's going to control what the default capacity is if we go and call the constructor that we're going to be making without specifying a capacity explicitly. Constants are normally marked as public so that they can be used anytime that this class is accessible. So I'm going to go ahead and make this particular field be public. But I'm also going and tagging it as static and final, which means that it can't be changed once it's created. So effectively, it becomes read-only. This is going to be an int, and the naming convention for constants in Java is that they're in all capital letters, and that if you had what would be spaces between multiple words, you go and use an underscore. I'm going to set the default capacity to be 25. And then I'm going to have two protected fields to actually support the internal operation of this queue. The first is going to be an array of type T that I'm going to call data, and that's going to store the contents of my queue. And then I'm also going to make a protected int field called size just to keep track of how many things we have. When we create a new instance of an array-based queue by calling its constructor, there's two things that are going to happen. First, we have to go and create a new array to store objects, and it's going to have the specified number of elements that we either pass when we go and call the constructor or come from our default capacity, and the resulting array is going to be stored in the data field. Now this array is going to at least directly store objects. We can go ahead and cast it to store that's going to store t-type, but we can't directly create it as being a t-type array because you can't make generically typed arrays in Java. Once we have that array made, we want to make sure that our size field is set to 0, just to indicate that there's nothing that's actually being stored in the array. We can find the capacity of our array by going and accessing the length field of the array, so there's no need for us to have a separate field to keep track of that. I'm going to create two versions of a constructor for this class, one that will have a parameter where we can specify the initial capacity that we want for the array, and the other that's going to just use the default capacity from the constant. Let's go ahead and do the one first that includes the parameter. So this will be a public method, and it's going to be called arrayQ, and I'm going to have it take an int called initial capacity. Since we're able to go and grow and shrink this array in the implementation that we're designing here, we're not forever tied to that size. That's just going to be initially where we're going to start off for our array. Inside of the constructor, we're going to go and create our new data array. And we'll say this.data is equal to a new object array of size initial capacity. And then I'm going to go ahead and cast that array to an array of type T. So I can cast it to that T type. I just can't make the array be of that T type initially. You can see here that Eclipse is giving me a warning about an unchecked cast. And that's basically because it doesn't have a way to absolutely guarantee that that's going to be a safe cast. I'll use the quick fix here in Eclipse to go ahead and add the suppress warnings annotation to right above my constructor here, just to specify that, you know, I don't want to have it show me unchecked cast warnings. And that'd be just to get rid of it from the problems list here, because I know this is an issue. It shouldn't really pose a problem, but there's always a risk. Once I go ahead and create that new array, I'm just going to double check that I've initialized the number of elements in my size field. So I'm going to say this.size is equal to 0. And I'll provide some JavaDoc for my constructor here. So this is going to create a new array-based queue with a specified initial capacity. And that initial capacity is my initial capacity. Let's go ahead and make our other constructor, which is not going to have any parameters. So this is going to be public, and it's going to be called arrayQ, and we'll have an empty set of parentheses afterwards. And the only thing that this constructor is going to do is it's just going to call the other one, and it'll go ahead and pass as an argument when it calls the default capacity constant. So to call that other constructor, I'm going to say this, and then in parentheses, I'm going to go ahead and pass the value arrayQ.default capacity. And we'll add some JavaDoc to create a new array-based queue with the default initial capacity. We're going to create a helper method to go and manage the size of our array. It's going to evaluate how many of the elements in our existing array are in use, and if it finds that we need more space, it'll go ahead and create a duplicate of the existing array that just happens to have more elements. If it finds that we have a lot of unused space, it's actually going to create a new replacement array with the same content but with just fewer elements. Our method is going to decide that it should go and increase the size of our data array if the size field, which is the number of elements we're actually using, is greater than or equal to the number of elements that are there. In reality, at most size should only be equal to the length. It should never be larger though. But what's going to happen here is if it realizes that we're out of space, it's going to go ahead and create a new array that has 50% more elements than what we have right now. And it's going to go ahead and copy the contents of the existing array into that new array, and then it's going to go and store that new larger array back in the data field, effectively replacing our original one. We're going to set up our method so it also looks at the case where we have an existing data array that's too large for the number of elements we're actually using. What we're going to say here is that if the size, which is the number of elements we're actually using, is less than half the size of our array, we're going to go ahead and create a smaller replacement array. What we'll do is go and create a new array that's going to be 2/3 the size of the existing one. And then we'll copy the data from our existing array into that new one. And we'll go ahead and store that new smaller array in the data field, effectively replacing our original larger one. Let's go into Eclipse and see how we can code this up. For managing the size of our array, I'm going to create a new protected method because this is just going to be internal to the operation of our array-based implementation here. And I'm going to call it manage data capacity. I'm going to give it a void return type. So we said we want to call this manage data capacity, and it doesn't need to take any input parameters. It doesn't really care what we're trying to do at the time we go and call it. It's just going to go and look at the number of elements that are there and figure out if it needs to grow or shrink, just solely based on the number of elements that are in use. It may be a case that it doesn't actually need to touch anything at all. Inside, we're going to start off here by determining basically if the array needs to be resized, and we'll kick that off by writing an if statement that checks to see if this dot size is greater than or equal to this dot data dot length. So if this is true, that means that we've actually used all of the elements, and we're going to have to make something larger in order to add more to our queue. What we're going to do in this situation here, if this is true, is we're going to make a new array that is 50% larger. I'm going to use the java.util.arrays class with its copyOf method here. CopyOf takes two parameters. The first is going to be the array that I'm trying to go and duplicate. So that's going to be this dot data. The second parameter is going to be an int with the new size of the array. So how many elements I want to have in the larger array. So I'm going to take this dot data dot length to get the current size, and to make things be 50% larger, I'm going to multiply it by 1.5. So I want to get something that has 150% the number of elements as the current array. But I want to think about this case here a little bit, because what happens if I end up with a case where I have, say, 3 elements right now, and I need to go in and expand it. 3 times 1.5 is 4.5. I end up with this fraction of an element, which doesn't make a whole lot of sense. I'm going to go ahead and round things up in all cases. So for that, I'm going to go and call math.ceil. This is going to take the ceiling of this value, which is the next integer that's larger than or equal to the size of whatever value I have here. So if I have 4.5, the next larger integer is 5. If this was already 5, 5 is equal to 5, so it's just going to return 5. The thing is that while ceil is going to go and pick an integer, it actually goes and returns double. And copyOf wants an int. So I need to take the result from calling the ceil method here and cast it back to an int so that copyOf is happy. CopyOf is going to go and return my new array, and I'm going to capture that back and store it in the this.data field. So this.data equals arrays.copyOf my array, and then the new size for that array. So that'll handle the case where I need to make things be larger. I'm going to add an else if clause for where I need to shrink my array. So I'm going to say here, else if this dot size is less than 0.5 times this dot data dot length. So I'm using less than half of the elements in my array. Then what I'm going to go ahead and do here is make a new array that is 2/3 the previous size. And my code here is going to look similar to what I had above. We'll do this dot data equals arrays dot copy of, and I'm going to copy the array this dot data. For the size, I'm going to cast to an int the result from calling math.ceil, and here I'm going to do this dot data dot length times 0.667, which is an approximation of 2/3. This way, even when I go and shrink my array, I'm still going to have some extra elements. I don't get into a case where I potentially shrink things and then immediately might have to come back and go and regrow stuff. I'm still going to have a little bit of buffer of free space to play around with. I'm not going to have any else clause here. Basically, what's going to happen is if I don't fall into either of these cases, then my existing array is an appropriate size and we're just not going to do anything. Since this is a void method, I don't need to return anything. I will go ahead and add some JavaDoc just to say that this grows or shrinks our data array as needed. Now that we've figured out how we can resize our data array, let's take a look at how we can add items to our queue. This is going to be a relatively straightforward process with our array-based implementation. So let's say here that we have an array that has 3 elements right now, and it's got 2 items in use. We're going to start off by going and calling our manage data capacity method to figure out if we need to make a larger array, and if so, we'll take care of that. In this case, since we have an empty element, we don't actually have to go and replace the existing array. Once we've gone and taken care of the array capacity, we're ready to go ahead and store our value, and that's just going to be in the first unused element. So that's going to be the element whose index is size. Since we have zero-based indexing, if size is 2, that means that the currently used elements are 0 and 1, and that 2 is actually free. Once we've gone and stored our value, we can go and increment what's in our size field to reflect that we now have an additional item inside of our queue. Let's go ahead to our enqueue method here, and we just have a couple lines of code. We want to go ahead and manage our data array size by calling this .manage data capacity. That'll handle creating a larger array if we need to. And then we're going to go ahead and store our new item in the first unused element. Now, I'm not doing any checks here to see if the item is null. The way we're implementing things here, nulls really aren't going to cause us a problem. We normally would not put a null value in a queue, but it's not going to lead to any null pointer exceptions or anything that's going to cause us a problem if somebody does. So to go ahead and store this, I'm going to do this .data, and then for the element, it's going to be this .size with the current version of size we've coming in here. We'll go ahead and set that equal to item. Once we have gone and stored our new item, we can update size by incrementing it. So we'll do this .size ++. If we want to take a peek at what's at the front of our queue without actually changing the contents of the queue, we're going to start off by making sure that there is actually something in our queue to begin with. If our queue is empty, we're going to throw no such element exception. Assuming that there is stuff in the queue, what we're going to do here is just go and return the value that's in the front element, which is going to be element 0 of our data array. In writing my peek method, I'm going to use the isEmpty method to figure out whether or not there's anything in the queue. So before I go ahead and code up peek, I'm going to take care of isEmpty. And as we've been seeing, isEmpty is really straightforward. It's just going to go ahead and check to see if our size field is 0, and if so, it'll return true. So I'm going to go return the result from the comparison. This dot size is equal to 0. With that coded, I'm going to go ahead and work on peak, and I'm going to go and throw an exception if my queue is empty. So I'm going to check to see here if this dot is empty. If this returns true, that means that there's nothing in the queue. And we're going to go ahead and throw a new no such element exception, and we'll pass along the message that the queue is empty. And I'll need to go and import the no such element exception class from java.util. So I'll just use the quick fix there in Eclipse to take care of that. Assuming that we actually have stuff in the queue, we're going to go ahead and return the item from the front of it. So that's going to be returning this dot data at index 0, with 0 being the front of our queue. And that's all we need to do to peek at things. Let's say that we want to go beyond peeking at what's at the front of our queue and actually go and remove the value. What we're going to have to do here is actually go and basically start off with a peek. We're going to go and take the value that's at the front of our queue, and we're going to store it in a temporary variable. Once we've done that, we're going to loop. We're going to start at index 1, so the second item in our data array. And as long as our counter variable I is less than size, the number of elements that we're actually going through and using here, we're going to go and take the value that's an I, and we're going to go and copy it into the previous element, I minus 1. So this is going to effectively shift everything to the left by one element, which will go and mean that we'll replace the contents of element 0, the value that we removed. So we're just kind of working our way through, going and copying stuff backwards. Once we get to the end of the elements that we actually have data in, we're going to set that last element, size minus 1, to null to signify that it's no longer in use. We'll continue things by going and just decrementing the count of items in the queue. So we'll reduce the value of size. Once we've gone and removed our item, we want to make sure that we don't have a data array that's too large. So at the tail end of things here, we're going to call our manage data capacity method, as opposed to when we were enqueuing things where we did it up front. Once we've gone and swapped out our data array, if we needed to shrink it to a smaller size, we can go ahead and finish up our dequeue method, and we're going to return the value that we removed. Just as we did with our linked implementation of a queue, we're going to start off our dequeue method by calling the peek method. This is going to get us the value that was at the front of our queue, and it's going to be stored here in this front data variable. But before it does that, it's going to make sure that there actually is something in the queue. So we're going to allow peek to handle throwing the no such element exception if there's nothing in the queue. Once we've safely stored the value from our first element, we need to go and shift over the contents of all the remaining elements so that we don't have any gaps at the front of our array. We'll do a for loop for this, and I'm going to start off my counter I at 1 because I want to start at the second element in my array, because I'm going to copy that to the left one spot. So I'm starting at 1 to make sure there actually is a spot to the left I can go ahead and copy. For this here, I'm going to go and loop while I is less than this .data.length. So if I were to only have an array that had one item to begin with, what's going to happen is that this loop will never run. So I don't have to worry about array out of bounds issues. Each time through, we're going to go ahead and increment I. And then in here, we're just going to do a simple assignment statement. So I'm going to say this .data sub I minus 1, so the value to the left of our current position, is going to be equal to this .data sub I, the value at our current position. Once we've gone and shifted everything, we're going to set this.data sub this.size minus 1, which is the rightmost element that we actually had something stored in, and we're going to set that to null. We'll go ahead and update our size by doing this.size minus minus. And once we've done that, we want to go and see if we need to shrink the array. And for that, we'll call this.manage data capacity. And then the last thing we need to do is just go ahead and return the item from the front of queue. So I'm going to return front data. And that goes and finishes up the dequeue method. Let's go ahead and tackle our size method, which is just a single line going and returning this.size. Let's take a look at how we can iterate over the contents of our queue. Here, we're going to create a loop where we just start at the front of the queue, so in element 0. And we're just going to keep on looping until we get to element size minus 1. And that's going to be the last element that we're actually using. So along the way, at each iteration, we can go and print out the value or store it or whatever we're trying to do. The last method that we need to finish is our toArray method. For this, I could actually go and use the process we just looked at to iterate over the queue. I could go ahead and have a for loop that would start at the beginning and go and copy each element over to a new array. Since our data is already in an array, though, I can actually do our toArray method much simpler. What we're going to do is just use arrays.copyOf. And here we're going to size it so it only has the same number of elements as we're actually using to store data. So I'm going to go and return when I get back from calling arrays.copyOf on this.data. And for the size, I'm going to say this.size. So if there are any unused elements at the end, they're just going to be dropped. They won't be included in the copy. But that goes ahead and finishes up our array-based implementation of a queue. For this lecture's participation project, I'd like you to download the starter code that is posted in eCampus. Inside you'll find a copy of the linked queue class that we created as part of this lecture. I want you to modify it to add a contains method that's going to return a Boolean value indicating on if the provided value is stored in the queue. When you go and turn it in, all you need to do is submit the linked queue class with your modification. That's where we're going to end things for this look at basic queues. If you have any questions, join the Q&A session or send me an email. Thanks and have a great day.